Section 4.2, Day 2. In our previous lesson, we learned something brand new that probably mathematically you've never seen before, and it's called the factorial. And it's technically a very, very easy idea to use. You simply find the button on your calculator, and for factorial, you type it in, and you see a nice sweet 24. You type in 6 factorial, and you see a 720. And then if we remember this from our previous lesson, what is a factorial? A factorial is really a way to say how many ways can something be arranged. I gave you a couple of examples, moving things around. A very simple one would be my whiteboard markers. If I have 3 whiteboard markers, in how many ways left to right could I arrange them? Well, I could have red, black, and then blue. There's one way. I could move this over, and then there's a second way. I could have blue first. There's a third way, and I'm not going to keep going with the options. That is what a factorial does. When you type in 3 factorial into your calculator to get a value of 6, there would be 6 different ways left to right I could arrange my 3 markers. Now there's many, many useful things in factorial in the world of probability and in statistics. Right now we're just trying to get a beat on it with simple little things like putting people in a certain order in a seating plan in a classroom or an Olympic race. Now formally, what does factorial look like? What would be the formal notation? You can take any number. So what I'm going to do just for an example is I'm going to write down the number 7 factorial. Yes, we could type it into our calculators and we would get a number in the thousands, but what does it actually mean? And we did this last day. 3 factorial actually means 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1, and you guys get the pattern. What you see right here, again, for the second time, is a formal way to write it. You can write any factorial, any number you want, as n times n minus 1 times n minus 2, and it could keep going, n minus 3, n minus 4, n minus 5. And what it always does is it always goes down to 3, 2, 1, if there's enough numbers. So for example, 7 factorial, you could say is 7. What's our first number? The next number would be 6. That's when you take 1 away from the original number. The next number would be a 5, and then you'd have a 4, and then a 3, a 2, and a 1. So any factorial can be written in this manner. Now, right away, you might be wondering, well, what good does that do for me for actually doing questions, doing probability questions, working at a university level in statistics? It does eventually help us, but right now, what we're going to be able to see is we can do some fairly theoretical questions to really try to master what actually is this process and what is going on. So in your notes, in your PDF notes, I did call it a very theoretical question, and the key word was simplify. Simplify always means to somehow break it down and make it smaller. That might seem like a bit of a farce today because it's going to look rather weird. So let's say this was the question that was given, and what we were supposed to do was simplify this. Here's how we're going to begin. We're going to actually just write it out in its full, in its entirety. If you're going to write out n factorial, that means n times n minus 1 times n minus 2. You could keep going. You could go n minus 3, n minus 4, and it always goes down to 3, 2, and 1. Here's where you're going to have to be at the edge of your seat and really paying attention. How could you write n minus 2 factorial? Well, you always start with the original. n minus 2, the next smaller, taking 1 away, would be n minus 3, n minus 4, n minus 5, n minus 6. And it always goes down to 3, 2, and 1. That's going to take a little bit of practice to get used to. And here's where the fun begins. And then we're at our final answer. If we were supposed to simplify and everything is multiplied together, anything that is up top, same as bottom, can be crossed out. You can cross those out. You can cross out n minus 3 and n minus 3 because anything divided by itself is 1. These cancel out, these cancel out, these cancel out. And then you're asked, what are you left with? Well, you have an n and you have an n minus 1. And that is what we need to do in this question. We need to simplify this as far as we can. And this is as far as we can actually go. I know you're thinking again, where in the real world would I use this? Probably not a lot of places, but we need to really master what is a factorial, and then we can move on to some of the higher level problems. So the second example I gave you gave n plus 3 factorial divided by n plus 1. So again, I know right away it looks weird. Why are we starting with n plus 3? Why isn't it just n like what was in our notes? What we're saying is we can take any number and we can write it out in its definition, its factorial notation. So if we take the numerator, n plus 3, and go 1 smaller, it'd be n plus 2. Then go 1 smaller, n plus 1. You could have then an n. You could have an n minus a 1, n minus 2, n minus 3, and it always goes down to 3 times 2 times 1. Now, what would the denominator look like? And I want you to watch where I'm going to start to write. N plus 1 factorial. Well, you start with n plus 1. If you go one smaller, it's just an n. Another one smaller, an n minus 1, n minus 2, n minus 3. Notice I've just lined it up. I didn't start it way over here because I saw what was coming down the pipe. And now we are ready to do some good, clean fun. Anything that is up top that is also on the bottom can be crossed out. Then you'd ask yourself, what are we left with? What are we doing? Well, we're trying to simplify. And I know it doesn't look that much smaller, but this is the simplified version of what we were looking to do. Now, our final question in this category. Our final question, you have to really watch what is in the numerator, what is in the denominator, and you might start to feel just a little bit more comfortable with the whole writing it out, because it does look very weird. We are jumping theoretical very, very quickly. So our final example in this bank was n factorial over n plus 1 factorial. Let's simplify it. Let's break it down as much as we can. I'll start with the numerator. The numerator has n times n minus 1 times n minus 2. It really does feel like the full definition of a factorial. Goes down to 3, 2, and 1. Now our denominator. Our denominator, we start with the first number, which is n plus 1. Then we start to go smaller, and hopefully you're getting the hang of this. It's very theoretical. Again, it's tough to see the real world purpose behind this. But what we're trying to do is expand out these using the formal definition, and anything that's up top and bottom cancels out to just 1 so they can go away. Then you'd be saying, what are we left with? And you got to be careful on this guy. Yes, you're left with an n plus 1, but the question is, where is it? It's in the denominator, so you need to put a 1 on top to keep your place, so you realize that that's in the denominator. And we're going to go to our final type of question. And our final type of question is where you would need your calculator. And I would challenge you to pause the video and actually try a couple of numbers. And the technique I'm going to show you guys, just due to time restraints, is going to be to use trial and error. So what we're going to have is this n factorial over top of n minus 2 factorial. But now look at the difference to number 3. Now we actually have a number on the other side. It's an equation. We have an equal sign. And what you're going to be trying to do is to solve what value of n, and it's got to be an integer. It's got to be a number, not a decimal, that's either positive or negative, so like a 1, 2, 3, 4, or a -5, -7. I'm going to just say a really quick and easy way to do it is you could just go trial and error. You could put in numbers for n, use your calculator, and see if it works. So my favorite number is 7. You could go 7 factorial divided by, this would be 5 factorial, hit equals, see if you get 90. No, I know you wouldn't, because you already see the answer. The answer is 10, and I challenge you to try it. Type in 10 factorial divided by 8 factorial, hit equals, you will see 90. You've just solved the equation. And no, we didn't use a formal technique. I'll show that at a later day. We are just trying to say trial and error. What could you do? So the next one, kind of a tricky little guy. If we were face to face, I'd probably challenge the class to try it and see who could get it the quickest. Even after just one example, you get the idea. What we are trying to do is to figure out what number can we put in for n. It won't be a fraction, it won't be a decimal, so that when we do the division, it's 6. So here's what most people would do. They would put in a number like 5, and they would have 9 on top, 7, and they would go 9 factorial in their calculator, divided by 7 factorial, hit equals, and they wouldn't get the answer, and they would keep trying. But here's what a lot of people don't realize. It could also be a negative number. And that's what the answer in this one is. Now, again, I challenge you to try it. If you put a -1 in, you'd get a 3 and a 1. 3 factorial divided by 1 factorial, you'd get a 6. You've solved this equation. Now, I know that there's still a number 5 in your PDF notes. Here's your second challenge I want to throw out. It's kind of a silly little question that you can still do mathematically, but it really doesn't have a real life purpose. I want to just throw out a challenge. I want you to look at number 5 in your PDF notes, see if you can make a little bit of sense out of it. And then again, I told you in a further day, I would show you a technique behind this. On the day that I show the technique, I'll talk to that question. So my challenge of the day is to see if you can figure out number 5, but don't worry, you won't be tested on it.